Hello, everyone. It is a pleasure today at the Barcelona Economic Society to host Professor Emi Nakamura from the University of California, Berkeley. Professor Nakamura received her PhD from Harvard University, and her work focuses on monetary policy and fiscal policy, business cycles, and also empirical macroeconomics, whose for which her work is very renowned. She's made very important contributions to this field, and for which she received the John Bates Clark Medal in 2019, which is one of the highest honors in economics. She's also an advisor to the Congressional Budget Office, so she's also very involved in policy as well. So we're very thankful that she has made time in her schedule for us to talk about her work regarding empirical macroeconomics, which is one of the main challenges of the field. So thank you, Professor Nakamura, for being here, and the floor is yours.
Thank you. Well, it's good to be here, and thank you for that introduction. I am going to talk about natural experiments as a guide to macroeconomic policy. I want to say I'm mostly going to be showing you a bunch of graphs, but I don't have too much material, so you're welcome to ask questions. Okay, so let me start with some themes that Carlos, I think, already introduced. We have these very important questions in macroeconomics. So what are the effects of monetary policy on the economy? What are the effects of fiscal policy on the economy? These are, of course, questions that are central to policy debates right now. You see them every day in the news, as well as in academic discussions. And the challenge that we face in macroeconomics is that theory alone doesn't speak with a unified voice on these questions. So, for example, if you consider a neoclassical model, a real business cycle model, if you double all the money in the economy, the prices all double and nothing happens. So monetary policy has no impact at all. And similarly, there's a huge range of possible answers you could get for the effects of fiscal policy. So typically in neoclassical models, the effects of fiscal stimulus are very small. In contrast, in a Keynesian model, those effects can be large under certain circumstances. So how do we decide, which of these predictions from models to believe? Well, clearly, like in any science, empirical evidence is key to be able to distinguish among different possible theories of the world. So these are pretty old questions. What are the effects of monetary policy? What are the effects of fiscal policy? So you might ask, given that these are old questions people have been thinking about for a long time, why don't we know the answer? And I think the crucial issue in macroeconomics is that identification is extremely challenging. So if you think about monetary policy, so when does the Federal Reserve or the ECB raise interest rates? It's of course not at random moments, right? It's in the recent period, there were big increases in interest rates, but that was in response to an unprecedented inflationary surge and a really overheating economy. When did they lower interest rates, to zero in the recent past? Well, there was, of course, during the COVID recession or during the financial crisis. If you were to just look at what happened, in response to these kinds of events, you might get very puzzling responses, right? You might think, well, every time the Fed or the ECB lowers interest rates, we have a recession. But I think everybody in this room knows that wouldn't be the right conclusion to draw because there is a reverse causality problem. So the reason that the Fed or the ECB was lowering interest rates during COVID, it had a lot to do with COVID, right? So then you can't conclude that what happens thereafter is a consequence of the monetary policy. You have to think about what caused the monetary policy as well. And so that is a major challenge that we face in macroeconomics, that there are these big questions that we want to have answers to and that we've wanted to have answers to for decades. But it's not so easy because the variation that we have is very endogenous, and this is the kind of classic problem of distinguishing cause and effect in economics in general. But in macroeconomics, I think it's particularly challenging because, for example, it's very difficult to do, true experiments. I think this is for a reason, right? Because macroeconomic policies are so important. So you could imagine doing an experiment with monetary policy or with fiscal policy, but there are pretty clear reasons why macroeconomists are not allowed to do this because these things have such large effects on the world that experimenting with them is very problematic from an ethical standpoint. So, it's a very challenging issue. It means that some of these really key questions in macroeconomics, we're still struggling with them. Even a long time after the Great Depression, when arguably, many of these macroeconomic disciplines sort of started to exist. But fortunately, we do have some new ammunition in dealing with these important questions. And I was chatting a little bit with Carlos at the beginning about what some of this new ammunition is. Well, on the one hand, there's been an explosion in the availability of big data. So it used to be that macroeconomists only used macro data, but unfortunately, there's not that much of that, right? So, there's only, 60 years of post-war data, very high quality sort of standard macro time series like GDP and so on. But for a lot of questions, you might be able to learn something from the microdata. And of course, the availability of microdata has really exploded. An example of that I'll talk about more is in the case of prices data. So, when I was doing my PhD, one of the things that was just getting started was access to the prices underlying the consumer price index, both in the United States and in countries, around the world. So you see the headline inflation numbers, but those headline inflation numbers, they come from underlying surveys or data collection on individual prices. And so, when I was doing my PhD, that was sort of just when a lot of central banks around the world were starting to make those kinds of data available. And of course, you can learn a lot more by looking at the individual microdata about how prices are really changing. Another example in monetary policy is the availability of high frequency data on asset prices. So for identification of monetary shocks, I think this has been a really watershed moment. It's possible to look at exactly what's happening at the moment when the Fed or the ECB makes a policy announcement, and that has been very impactful for research. A second, big innovation has, of course, been, recently AI. So this has been expanding even further the availability of data. So we were talking a little bit about economic history. There are lots of things that previously were not really machine-readable data sets that now are. And then there's improvements on the side of empirical methods. So there is a whole range of empirical methods from diff and diff, various forms of cross-sectional identification methods to regression discontinuity, which have been developed mostly in applied micro, but have very fruitful applications within macro. And so these are basically technological advances which I think can help drive advances to these very old questions in macroeconomics that we've been struggling with for a long time, but where I think there's real hope that we can make progress on them using these kinds of new technologies. Okay, so I'm going to talk about a bunch of examples. I think for empirical macroeconomics, to some extent, you have to learn from examples, although I'm not going to go into very much of the technical detail, but of course, in many of these cases, there is some technical detail of exactly how you implement these methods. But I'm going to sort of focus on the ideas of how you would think about a natural experiment as being able to provide some information about a macroeconomics question, because that actually was traditionally a big issue in the field. That people would say, well, the question we want to really learn about is this macroeconomic question. So how can we really learn anything from sort of microeconomic data? So that's something that I want to speak to. Okay, so I'm going to have 5 sets of graphs, as I said. Feel free to interrupt me. The first one will be about Phillips curves. The second, monetary policy shocks, fiscal stimulus. I'm going to talk about declining employment rates. and then finally exchange rate depreciation. So a pretty wide range of topics. Okay, so this is a picture pre-COVID of the Phillips curve. So on the x-axis, I have the unemployment gap relative to some notion of the natural rate. On the y-axis, I have the year-over-year change in inflation. So this is sort of what you might think of as an old Keynesian Phillips curve. It's what Stock and Watson referred to as a Phillips correlation. So they were being very careful about their language with regard to identification. And I had three lines. The first line is for 1960 to 1983. So that's the period right around, very high inflation in the United States and many countries, but also when there was restrictive monetary policy. And people usually talk about this as a period of a very steep Phillips curve. Then for the next two time periods, 1984 to 1999 and 2000 to 2019, you see this Phillips curve really flattening out. So it's hard to remember this now, given all that's happened with COVID. But in 2019, as of January 2020, right before COVID, the dominant discussion actually with regard to the Phillips curve was the flattening Phillips curve. That was what people were really talking about. And why was the Phillips curve flattening? Now, this is a really challenging question. How do you, this is, as I said, is time series variation, and Stock and Watson referred to this as a Phillips correlation because lots of things could be moving around the unemployment rate. So from micro, when you're estimating a demand curve or a supply curve, you can't just run a regression of P on Q. Because then you might have this cloud of points. Who knows whether you're tracing out the demand curve or the supply curve? Whether it's flattening or not flattening, it's hard to know what that would tell you. It could just tell you about the mix of shocks. So that's a big challenge that arises in the Phillips curve literature as well. So how could cross-sectional data help you? Well, one idea, which we sort of drew on in a paper on cross-sectional identification of the Phillips curve, was to try to use variation across different states in the United States to shed light on this. So here I'm showing you the unemployment rate for these three different states: California, Texas, and Pennsylvania. And what's interesting about these three different states is obviously there's a lot of co-movement. So, these peaks, this is the unemployment rate. So the peaks are obviously the recessions. And you see the Great Recession, the financial crisis is a big peak. This is before COVID again. But you also see differences. So, notice that California has a much bigger spike during the Great Recession. That's because there was a much bigger housing crisis, basically, during the Great Recession. You also see that Texas actually has an additional recession. And that has to do partly with the fact that Texas is an oil-producing state. So from a cross-sectional standpoint, one way of using this information is to try to ask the question: when California has a much bigger recession than Texas or Pennsylvania, do we see that there's also a bigger decline in inflation? So that's essentially kind of a cross-sectional identification scheme. So that's an approach that's very different from the standard approach to identifying the Phillips curve, because potentially, if we're looking at differences in differences, for those of you who are kind of familiar with applied micro type of language, you might not be using the aggregate variation at all. And it turns out that for this question, it makes a huge difference. So here I'm showing you two plots. On the left-hand side, I'm showing you sort of the conventional estimates of the slope of the Phillips curve before 1990 and after 1990 using time series methods. And you can see that there's just this dramatic flattening. So it looks like before 1990, during this period that is very famous for having this big disinflationary episode, there's a very steep Phillips curve. But that by the time of the Great Recession, actually, the financial crisis, you saw big increases in unemployment. I mean, including in Spain, I think in many countries in Europe. But actually, you didn't see much happen with inflation. So that was a big part of the conversation about inflation before COVID. But interestingly, once you have time fixed effects, and so you're kind of taking out the common variation, these lines line up much more closely. So it looks like there's much less instability. It actually looks there's a much more sort of systematic relationship between the unemployment gap and changes in inflation. So what's the intuition for this? So, I mean, obviously I don't have time to get into all the details, but one crucial thing to understand is that in the United States and in many other countries around the world, there is a huge change in what people call the anchoring of longer term inflation expectations. So, around 1980, as I said before, there was this massive inflationary surge. And as a consequence, people really expected inflation could remain high for a long time. And here I'm showing you a picture of survey expectations 10 years out of inflation in the United States and actual inflation. So the actual inflation is the black line and the survey expectations are the gray line. And you see that around 1980, when there was this, big inflation surge in the United States, but not just in the United States, in many countries around the world, you see that these track each other roughly one for one. So whenever inflation, went up, people thought that it could be basically permanent. And when inflation fell, they thought that also might be permanent. So it was very much a world where, people had to see it to believe it. So they didn't really believe anything the central bank said about, the 2% inflation target. But as inflation fell, then their inflation expectations fell. And the impressive contrast, and it got even more impressive during COVID, is versus the second half of this time period after 1998, where you see that inflation expectations in the long run stabilized around almost exactly 2%. And sort of no matter what happened with actual inflation, they just stayed the same. And the most dramatic example of this was, in fact, COVID, when inflation in the United States went up to 8% and longer term inflation expectations barely budged. And so coming back to this methodological point, one of the things that the diff and diff type of methodology, the cross-sectional identification, can give you is an ability to difference out aggregate changes, like changes in the anchoring of longer term inflation expectations, from the estimation of perhaps the relationship you're trying to estimate. So, in the case of our paper, we're trying to estimate the slope of the Phillips curve. We're able to kind of connect that very directly to an equation in a regional model, where long-term inflation expectations actually end up being a constant term in the equation that's shared across the different states. And so, which lends itself very nicely to this kind of cross-sectional identification approach, and sort of gives you an intuition for why the left-hand graph, which doesn't include these time-fixed effects and therefore includes all of the aggregate variation, including in the anchoring of longer-term inflation expectations, could give you a very different answer from the right-hand side graph, where we have these time-fixed effects. And so all the variation is coming from these regional differences. This is a method that has been used as well, in the COVID period. So a former student of mine, Andrea Serrato, and his co-author Giulia Gitti, they looked at this for the United States in the pre and post-COVID period. So here they're using city-level inflation rates, and they're looking at the relationship between, again, it's an instrumented version of the unemployment rate and the inflation rate. And, mainly what they're looking at is the extent to which it looks like the Phillips curve steepened during the COVID period. So pre-COVID, here's the blue line, sort of similar to in our paper. And post-COVID is the red line, and you see that there is some steepening. So they're able to kind of assess the extent to which a part of the inflation that we saw post-COVID was sort of associated with the steepening Phillips curve using this type of cross-sectional identification approach. Okay, so that's my first example, estimation of the Phillips curve. So now let me talk a little bit about monetary policy shocks. So here's where high frequency data has been very impactful. Okay, so let me start with a graph of just the interest rate. So this is a graph of the Fed funds rate, the policy rate for the United States. It goes back to 1955. It has this very familiar sort of tent-shaped pattern, reflecting the fact that around 1980 there was this high inflation period that I was just mentioning. And the pattern for interest rates in a lot of countries bears some resemblance to this, because a lot of countries had problems with high inflation around 1980. And the challenge with trying to, again, assess the impact of change in the interest rate on the economy is this endogeneity problem. Because, when you look at this graph, one of the reasons that we spend so much time talking about interest rates when we teach undergraduate economics is because it encodes so much information about what's going on in the economy. So you can actually read off from this graph the time of all the recessions in the United States. There was a recession here in the 1990s. There was a recession here. This was the dot-com recession. And here's the Great Recession. So you can kind of read off where the recessions are by when the central bank was lowering interest rates. And also you can read off actually the severity of the recession. So here you see that interest rates were actually zero for a very long period of time, and that reflects the fact that this recession was actually so severe. Sorry, this is the 3-month T-bill rate, so it's not the Fed funds rate, but sort of a very short-term interest rate. So this makes it very challenging to know what the effects of central bank policy are, because you see, again, the interest rate fall during a Great Recession, and then you see a really bad recession. So can you conclude that the monetary policy lowering interest rates caused the recession? Well, no, because a lot of causality runs in the opposite direction. But the cool thing about having access to high frequency data is that there's actually a little bit of a mini experiment that's kind of embodied in all monetary policy announcements. So this is something that was leveraged in a paper by Gurkainak, Sack, and Swanson. So I'm showing you sort of a picture from their paper here. And what they're showing is the impact on sort of tick by tick, trade by trade data on the prices of futures contracts. So an appealing thing in terms of natural experiments is that the timing of central bank monetary policy announcements is known in advance. The reason this is appealing is that when you're trying to analyze experiments, you don't want things to be endogenous, right? You want things to be held fixed to economic circumstances. So it's helpful that central banks announce in advance a calendar of when they're going to make their announcements. And in the United States, during this period of time, it was 2:15 p.m., that they would announce this on a Tuesday. And so what you can see, so this is the price of this futures contract, and you can see this big jump right at the time of the press release. So it's pretty clear that the changes in futures prices that were happening are not a consequence of other macroeconomic news that might have caused the interest rate change, but they're clearly caused by the monetary policy itself, because what else is happening at this 2:15 time? I mean, and that's something you have to think about. If the time of the announcement was 8:30 a.m. on a Friday, that would have been a bigger problem, because that's also when the employment news comes out. But fortunately, this time is something where nothing else is being announced. So then the question is, how do these announcements impact the economy? So in some sense, this is sort of just direct evidence that they affect interest rates. But in macroeconomics, in all of these models that I was mentioning at the beginning, both neoclassical and Keynesian models, the central bank can control the nominal interest rate. So the question is really the extent to which they can control the real interest rate. But fortunately, that too, we have financial market data on in many countries, not all countries, but for the United States, there's an active market in what are called TIPS, inflation protected securities. So it's essentially a trade on the real interest rate, taking out, the inflation that is announced by the Bureau of Labor Statistics. Similar markets exist in England as well. And this gives us a much more sort of conclusive test across the different models, because in a neoclassical model, while the central bank can control the nominal interest rate, what happens when it moves the nominal interest rate is that inflation will jump around to keep the real interest rate constant. Real interest rate in a neoclassical model will just be pinned down by economic fundamentals. So what the central bank does is not affecting the real interest rate, and as a consequence, not affecting the real economy in the same way. Whereas in a Keynesian model, the central idea is that the price is adjusted in a sluggish manner. And as a consequence, the central bank is affecting not just the nominal interest rate, but also the real interest rate. So we can actually look at that in the data, because we have markets for these real interest rates, and we can look at exactly at the time of these monetary policy announcements, when we know the changes in the nominal interest rate are due to the monetary policy, what happens to the real interest rate? So that's what I'm showing here. And you can see that there's a very strong relationship. So when there's a FOMC announcement that changes the nominal interest rate, it doesn't just affect the nominal interest rate, it passes through almost one for one into the real interest rate. And this is equivalent. You might have heard of the notion of break-even inflation. There are these options-based inflation measures that kind of compare the asset-based estimates of the real and nominal interest rate. This is equivalent to saying that markets don't expect much of an inflationary response to these nominal interest rate shocks. And so this is, another way in which we can use high-frequency data on nominal and real interest rates to sort of test these theories about the effect of monetary policy on the economy. Another, fascinating sort of piece of data that we can get nowadays is data on expectations. So this is something that has become increasingly widely used in economics. So these are data from the survey of professional forecasters. Here I'm showing you sort of the second half of that tent-shaped graph I showed you earlier with the decline, the general decline in interest rates in the United States from around 1980. But what I've added, sometimes people refer to this as a hair plot. It's a plot from the survey of professional forecasters of interest rate forecasts over the next 4 quarters. And what's sort of fascinating about this graph is the extent to which these are professional forecasters sort of repeatedly believe in a much more mean reverting process for the interest rate than what actually occurs. So just to give you an example from the Great Recession. So during the Great Recession, no one saw it coming when at the beginning of the financial crisis, how incredibly long this recession was going to be and how long interest rates were going to be at the zero lower bound. In fact, throughout, they kept expecting that interest rates would sort of go back to normal. And it was only by sort of, later on in this recession, 2011, 2012, when the Fed started announcing that they were going to keep interest rates at zero for a long time, that these expectations about interest rates really collapsed to zero. So this kind of data on survey expectations is another very interesting source that we can use to think about how people are forming expectations. As you know, expectations are a big issue in macroeconomics. So do people have rational expectations? Are there important behavioral forces? Another question is how much information they have. So, we have a paper that starts from this fact, and then we are still thinking about a rational model, but we're thinking about a rational model in which people just don't know what the rule is, and as a consequence, are trying to learn about it, and that's something that can generate these kinds of patterns in the data. Okay, so that was monetary policy. Now I'm going to talk a little bit about fiscal policy, which is of course something that's coming back into the news a lot recently. Fiscal stimulus is another macroeconomic policy question for which it's very important. The debate goes back at least to the Great Depression when there were Keynes, for example, emphasized the importance of stimulating the economy, the idea that you could potentially dig holes and even that could stimulate the economy. But the challenge is in terms of empirical estimates that, again, we don't really have good experiments. Because when you have fiscal stimulus, say, certainly during the Great Depression, but also during the financial crisis, the fiscal stimulus is happening for a reason. So you might see still a big recession, but how do you know what the cause is and what the effect is? Presumably, the fact that there was a big recession after the financial crisis, that wasn't just a consequence of the fact that there was all this government spending, but it was because of the financial crisis itself. So both the financial crisis caused both the government spending and also the fiscal stimulus, and it's very difficult to kind of untangle from the time series evidence what the counterfactual would have been without the government stimulus. So simple correlations really yield very problematic answers. And again, probably fortunately for the world, but it's problematic for macroeconomics. We don't get to do randomized trials on at least large amounts of fiscal stimulus. So what a lot of researchers have tried to do is to try to look for clever natural experiments. And, if you're interested in this topic, it's a very fun literature to read because there are all sorts of things that happen in different countries. There's a paper, for example, about Italy, which looks at mafia crackdowns and the consequences for fiscal spending in particular localities in Italy. There are all sorts of other sort of clever experiments you can look at. Our paper on this topic was using military spending for the United States. So the reason why military spending is interesting to study for the United States from the standpoint of this question is because it is so big. So most US government spending is on entitlements, things like pensions and healthcare and so on, and is very systematic. But one thing that has a lot of variation, but for the United States is also actually very large, is military spending. So here I'm showing a time series plot of national military spending as a fraction of GDP. For the country as a whole, that's the black line, but also for California, which is the gray line above, and Illinois, which is the light line at the bottom. And the main point here is that, you see the black line rising and falling with sort of general geopolitical changes in the United States. So, this is sort of the drawdown after Korea and then there's sort of the Carter-Reagan military buildup subsequently. So, Vietnam is the first part, and then there's the Carter-Reagan military buildup subsequently. And these variations translate in very asymmetric ways to different states in the United States. So on the one hand, California, you see very large responses to the aggregate fluctuations in military spending. And this has a lot to do with the fact that California builds airplanes. And so there's a big effect of changes in military spending at the national level in California. In contrast, in Illinois, you see almost nothing. So whatever's going on with military spending at the national level, whatever war the United States might be involved in, it doesn't really affect Illinois very much. And so, this is the kind of graph that makes you think that, again, some kind of a differences in differences type of approach might be something that would work. And so basically the question that we're asking is, does one see increases in employment, in state level output in California relative to Illinois that sort of correspond with these relative changes in military spending in the two states? And in fact, you do. So here I'm showing, a demeaned change in military spending on the x-axis versus state level output on the y-axis. And the fact that most of the points lie in the upper right-hand quadrant and the lower left-hand quadrant is sort of indicating that there is this positive relationship, that it tends to be the case that when there's a lot of spending, military spending in the country as a whole, and as a consequence, a lot in California relative to Illinois, that we tend to see the California economy growing relative to Illinois. So I think, for the typical person, this would sound, completely obvious. Like, isn't it pretty obvious that if the government spends a lot of money in California, that the economy is going to expand? But actually, in these macroeconomic models, there are big differences. So the benchmark in a neoclassical model for fiscal stimulus is actually close to zero. The intuition is that if you're at full employment, if output is sort of determined by the efficient level of output in the economy, then the government can spend money, but the effect will be almost entirely crowding out. Whereas in a Keynesian model, the intuition is that they're sort of slack. That the government can spend money and some of it's going to crowd out maybe private sector stuff, but there's enough slack that actually the economy will expand. So again, finding these kinds of results is something that you can use to test macroeconomic models. And again, the distinction between, the Keynesian assumption that there's some slack, that the prices are not adjusting instantaneously and fully. It has different implications for lots of policy questions, from the alternative assumption that output is completely pinned down by these fundamentals and that there's immediate and complete response of prices. So it matters, as I said at the beginning, for example, for monetary policy. But there's, a way that you can test the question using cross-sectional data, which is perhaps sort of a surprising thing, that you can be using a very different kind of data, but you can be testing these macroeconomic questions. So the fourth thing I want to talk about is declining employment rates. So I think this is, a very interesting topic. Again, it's something that there was a lot of discussion of before COVID. So the nature of the discussion you often heard was that recoveries had become slower. And this is a picture that you would see sometimes even in newspapers in the United States. Here I'm showing you what happens to the employment rate starting from the peak of each of these 5 recessions pre-COVID. And what you see is that, so here's one of them here is the Great Recession, and you see that was a very big recession. But the other thing is that you see basically sort of no recovery in the employment rate after the recession. In contrast, in the previous recessions, you see the recession. So particularly in the blue case, which is the 1970s, you see this recession, but then you see a very rapid recovery and sort of something similar in the previous in the subsequent 1980s recession. But then you seem to see this slowing until you have almost no recovery by the Great Recession. So this is something that a lot of people were sort of talking about. Why are there these slow recoveries? A lesser known fact is that there's this huge difference if you look at this plot between men and women. So actually, if you look at men, it looks like sort of, even though the Great Recession was much bigger than the previous recessions, all the recessions just look slow. Sorry, recoveries look slow. Men just don't seem to recover much from recessions, at least in terms of their employment rates. In contrast, for women, you see this massive change where in the 1970s, you barely see the recession, and then there's this just massive recovery. And it's just, in order of date, these lines. And by the Great Recession, you see that the women look just like the men. There's no recovery. So there's this huge distinction between men and women, and clearly a theory that wants to kind of make contact with why these slow recoveries were happening. And there have been quite a few papers on this topic. It needs to make contact also with the difference between men and women. Okay, so sometimes when you look at snippets of graphs like this, it can kind of, you can miss something. And in this case, it's very useful to not just look at these peak to trough graphs, but look at the whole time series. So here I'm showing you the whole time series of labor force participation rates for men and for women, and it helps start to give you an idea of what's going on. So what you see for men, and this is for the United States, but the facts are true for actually a lot of countries in the world, is that there's basically been a monotonic and almost linear decline in labor force participation for men going all the way back to 1950. It's actually a very old phenomenon, where it used to be that almost all men were participating in the labor force. But by now, the rate is less than 70%. I should emphasize that this fact is also true for prime age, for men who are old enough to work, but like less than 55, so probably not retired. But for women, in contrast, you see this rapid rise in the 1970s, 1980s. This is what Claudia Golden referred to as the grand gender revolution. But then you see it plateauing pretty dramatically. Starting in the 1990s and the 2000s. And by the 2000s, women appear to be almost on the same downward trajectory as men. So now you kind of can understand this picture. Why is there such a dramatic change for women? Well, there's this incredible upward trajectory early on in the time series where women are basically converging to men. But then it looks like by the late 1990s and early 2000s, the convergence essentially stops. And then women are just on the same downward sloping trajectory. So a question that, that has been asked in literature when you look at this graph is, to what extent could the female entrance of women into the labor market be causing men to exit the labor market? And that matters, empirically. It also matters in terms of thinking about like the policy consequences and the extent to which you could explain some of the graphs I showed you here from the gender revolution. Because to the extent that the gender revolution was bringing women into the labor force, but what men were leaving the labor force, then this might be a situation where there would be this sort of reshuffling of who was working, but it wouldn't necessarily affect these aggregate, quantities that macroeconomists are sort of most interested in. And it turns out that this has a very natural mapping into theory. So in a lot of models, balanced growth preferences models, they're sort of designed so that, what you could call productivity change, where women enter the labor force, because of wealth effects, it leads men to leave the labor force. And so this is something in our work on this topic, we sort of, draw out the implications of these models. But the question of whether women entering the labor force can lead men to leave is also something that you can test empirically. The big challenge, of course, is finding some source of variation of women entering the labor force. So the fascinating thing about the history of the United States is that if you look across states, there are big differences in how rapidly women were entering the labor force in this 40-year period I'm emphasizing, but they were pretty predictable. So in some places like Washington, D.C., there were always a lot of office jobs. And so women actually were always kind of working a lot in Washington, D.C. This graph I'm showing you on the x-axis, it shows you the gap between female and male employment rates in 1970. So the fact that Washington, D.C. is this big outlier, what it means is that women were working only 20% less, 20 percentage points less than men in 1970. But in contrast, in a state like North Dakota, the difference was 55 percentage points. So that's a very huge difference. In Washington, D.C., it's a fairly similar fraction, but in North Dakota, it's just a massive difference. But what's interesting is that this difference in 1970, it very strongly predicts the growth rate of female employment over the next 40 years. So essentially, there's an extremely strong convergence relationship between initial female employment rates and subsequent growth. So the places that were very, what you might call backward in terms of women working much less than men, like North Dakota and South Dakota, they just had dramatically higher female employment rate growth over the next 40 years. So the women were sort of catching up much more in these places than in the places like Washington, D.C., where women were already working a lot. So then here too, you can sort of see a natural experiment. So you can ask the question, so if women enter the labor market so much more rapidly in these states, in a model where women, when they enter, there are these big wealth effects and it pushes men out of the labor market, which is, an idea that is often discussed sort of in society, then you might think that these places, which had massive entry of women into the labor market, would see more exit of men, right? Because there was so much more entry over here than in Washington, D.C. But in actuality, you see essentially no relationship. You see essentially no relationship. There's, maybe, a tiny kind of relationship in that direction. This line is, slightly upward sloping. But there's no sort of appreciable relationship. So it looks like when women enter the labor market, as we saw, differentially in these different states, there was really no tendency for men to exit, and as a consequence, this passed almost completely just into higher total employment growth in these states. I think I see one
Yeah,
question.
there's a
Women
question
and yeah,
in the chat. Do you want me to read it or can you
yeah.
read it yourself?
If women entering the labor force leads men to hold on, just arranging my leads men to leave, is this sorting observed in the labor market? I'm sorry. Leads to declining procyclicality of labor productivity as observed in the literature. Well, see, we don't really find much of that effect. That's what I'm emphasizing here. We find basically no effect on men. So in principle, you might see that, but we really don't. We really don't find that in this data. So that's kind of the type of model that we're sort of trying to speak to with this type of evidence.
Yeah. So something that actually interests me about this is that, I thought of women entering or recovering faster in a recession about, complementing the housing income, or the household income.
Right,
Um,
exactly.
so um, what made me think about the one thing that made me think about this is that is the type of shock or you know if women maybe are better at working in offices and these negative shocks we are observing are destroying factory jobs, is there some, you know, is that related? Maybe
So I
I
think
think
there are sort
maybe
of
it's not because maybe if factory jobs were being destroyed in North Dakota, you'd see that negative relation. But
right,
I don't
right,
know.
right,
Do you
right.
get my point? Maybe I'm not
Yeah,
explaining
yeah.
myself
I mean,
well.
I think that so I think there are really two different things. So one is the cyclicality of male and women and female employment rates, which is different for the reasons you essentially described. So men tend to work more in manufacturing jobs and they tend to be more cyclical. And the second is this secular trend. But I think what's really striking about the secular trending is how old it is.
Right.
It
Yeah.
goes, all the way back to 1950. It's also not really about employment rates. It's really about labor force participation. So this is something that was striking to me. There are lots of sort of explanations one can think about for differential behavior of female and male employment rates, and particularly at sort of business cycle frequencies and so on. But I think there's something else going on over this much longer time horizon. I mean, I think the ideas that Claudia Golden describes for the gender revolution are very salient for what's happening with women. I think what's happening with men is probably something that deserves more attention. I mean, in our model, we actually model it as a wealth effect, So back in the early 1900s, and there's a very interesting paper by Per and others, which is documenting this fact about men for many different countries. And, intuitively, back in the early 1900s, in the United States, many other countries, there were many people who were sort of working in coal mines, maybe 7 days a week, very long hours. As the U.S. has become richer, I think it's reasonable to think that there has been a wealth effect on labor supply, and perhaps some of that we continue to see today as, for example, people's houses get bigger. A lot of the decline in the male employment rates has to do with people continuing to live with their parents, which is something that might have been much more difficult in an earlier era where people were living in a lot less space. But I basically think that what I find striking about this picture is how persistent the trend is. So you might think of various phenomena like robots or trade or even video games is something people have talked about in the literature. But it's hard to see a break in this time series, and so maybe it's lots of different things. But it's sort of striking how
Right.
how extensive the secular trend is.
Yeah.
I think it's a very interesting topic.
Definitely.
Okay, so
Yeah, sorry.
so
There are
here.
a couple of
Oh, sorry.
more questions.
Yes.
Um, so Abbas Musa says, from this data, are men really not working as before? Considering it is in percentages, I would imagine this just shows a difference in the workforce composition since more women are not working.
Uh, no, no, no. This is the percent as a fraction of men. The employment rate, employment to population rate. So this is really showing that less and less men are working, and actually this picture I was showing you before, this picture, so this is a labor force participation rate for men. This is the employment rate, over 24 since 1950, and so you can see that it's almost a linear trend. So no, it's really it's not the ratio. It's independent. This picture is completely independent of what women are doing. The only sort of channel for sort of one affecting the other is through this crowding out effect. Okay, so
Which you've seen that it's not the case,
that's
right?
right, which is small. Exactly,
Exactly.
exactly. But that's why it's sort of an interesting
Right.
economic
Yeah,
question.
yeah, yeah.
Okay, so let me talk about one more example, which is exchange rate depreciations. So again, this is an area where you see radically different predictions from theoretical models. So on the one hand, you have the simple textbook logic, which I think a lot of politicians adopt, which is that And exchange rate depreciation is good for the economy because it's easier to export, basically. But there's also a huge literature on contractionary depreciations. The idea that, when your exchange rate depreciates, it's harder to borrow. And so as a consequence, it might actually lead to a contraction rather than expansion. So this is exactly the kind of situation where one feels like empirical evidence is really important, because when you have theories in the literature that literally have different signs, it seems like it's a case where the empirical evidence is really important. So what is a challenge? Well, again, it's reverse causality, because exchange rates depreciate for a reason. If there's a negative shock to a country, maybe you see GDP go down and the exchange rate depreciates, but maybe one doesn't cause the other. Maybe it's that, the negative shock led to the exchange rate depreciation and also led to the decline in GDP. And it's very difficult to think about even what an exogenous shock to the exchange rate would even mean, because prices are endogenous. So what does it mean? So what we do is we look at a particular class of exchange rate depreciations that we call regime-induced depreciations. The idea is to look at countries which peg versus float to the US dollar, and to think about a scenario where these countries are sort of not the major US trading partners. So you can think about what's going on with the US dollar exchange rate itself is sort of independent to shocks to these countries. So for example, consider the case of Egypt and South Africa. So traditionally, Egypt has pegged versus the US dollar. In contrast, traditionally, South Africa has actually floated. And so as a consequence, when the US dollar depreciates versus, say, the euro, for reasons that have nothing to do with either Egypt or South Africa, it has this pretty significant effect on Egypt versus South Africa, which is that Egypt tends to depreciate versus South Africa. And so then the idea is that it's sort of for no fault of their own. This is determined by history, basically, why it is that Egypt pegs and South Africa floats. There's in Africa in particular, there's a lot of variation in exchange rates that has to do with history. There's a block of countries which is a French franc block, and then there's another block of countries which pegs to the dollar, and this has to do with kind of deep history of colonization and so on. But it continues to have an effect potentially today because of these exchange rate arrangements. So what do we find? Well, it turns out that on average, for the peggers versus the floaters, when the US dollar depreciates, that's what we're showing on the left-hand side. So, the US dollar depreciates, the peggers tend to depreciate. Okay, so this is international economics, so it's extra hard because all the signs are confusing. But up means depreciation, okay? So this is the peggers to the US dollar depreciating versus the floaters to the US dollar because the US dollar is depreciating. And then the question we ask is what happens to GDP? And it turns out that the economy actually also booms. So the result we find is pretty strongly in the direction of these depreciations, these regime-induced depreciations, leading to booms in the countries that are peggers at the time of a US dollar depreciation. An interesting, additional fact is that it doesn't turn out to align super well with the traditional, model where, the textbook model where there's an export boom, because we can actually look at what happens to net exports, and we don't see net exports increasing dramatically. In fact, we see them going in the opposite direction. So it really looks like some kind of a domestic boom. It's also not associated with a dramatic monetary easing. So in the end, the kind of theory we proposed is that it has to do with financial flows. So this was a case where, we were looking at this natural experiment and, it led to these sort of surprising results, actually. And we had to kind of think about new theories. Okay, so
Sorry,
I'm almost out of time. Yeah.
There's a question in the chat. Siet Abbas says, does it show some lags as in the J curve? I'm assuming.
I guess that, you do see a pretty long lag. So in our model, that's something that we have to model using sort of a lot of rigidity. So yes, in some sense. Okay, so and one thing that's very interesting, that we do is we look at a particular incident, which was this Plaza Accord, where the U.S. Treasury Secretary James Baker sort of talked down the U.S. dollar And then you can see actually the peggers versus the floaters after this time period, it looks like the peggers grew significantly faster than the floaters. So that's sort of an example of the type of effect that we're talking about. Okay, so I'm pretty much out of time, and I just wanted to mention one additional point. So I've kind of glossed over the details of the connection between these natural experiments and the macro theories. But in terms of how these type of natural experiments can contribute to the academic literature, it's important to emphasize that often these natural experiments aren't exactly the experiments that you want for policy questions. So for example, in the government spending case, you're learning about what happens when there's government spending in California relative to Illinois. But the question is it the same as what happens in response to aggregate government spending? And often there are additional channels at the aggregate level that you don't, have to deal with at the regional level to the extent that they get differenced out. And sometimes that's a very appealing thing for trying to estimate, particular parts of the model. But it's also something where when you want to take this final step of saying, well, what does this imply for the aggregate question of what is the effect of monetary policy or what is the effect of fiscal policy? Often it means that this ultimate, answer is going to come from a combination of theory and data. And so that's something where I think there are also kind of benefits that flow from macro to micro, because you'll often see, microeconomic studies, and here I'm showing an extremely well-known paper by Otter, Dorn, and Hansen on what's called the China shock. They're looking at the effect of, trade with China on local labor markets in the United States. And ultimately, they want to make a statement about the extent to which this China shock can explain, and here's the sort of sentence, aggregate declines in US manufacturing employment. But that's, of course, a statement about the aggregate. And typically, those kinds of statements about the aggregate, they'll run into challenges having to do with additional assumptions, additional features of the theory being important in determining what happens at the aggregate level. So for example, in the case of fiscal policy, when you study what happens in one state versus another, in some sense you learn what happens in a case where the monetary policy is sort of neutral, because you're never going to have different monetary policy in California versus Illinois. But at the aggregate level, when you want to study the implications of these estimates for aggregate implications, then you have to ask the question of how monetary policy will respond. So that's one additional piece. It's another thing that sort of makes empirical macroeconomics challenging. But I think that with all the technological advancements in terms of the availability of data, availability of new empirical methods, and even machine learning and AI, which contribute to all of this, I think it's an area that has a lot of potential. I see another question.
Yeah, I'll read it aloud. Yeah, so Siet again asks, for fiscal policy professor, use military expenditures. Do you think fiscal multiplier of developmental expenditures is the same as of military expenditures? If there's a gap, do we have any particular idea or numbers?
So I certainly think it's likely to be different. I don't think so I think there are some attempts to estimate that, but I think that's certainly an area where we could do more. I was actually recently, I saw, someone's research using, so the data that we were using at the time, over this long time period, it didn't have, too much detail or too much categorization. And so we didn't really analyze, these different types of military spending, for example, and our instrument really had to do with military spending. So we were focused on that. But, there are more recent analyses using the more recent sort of version of this data that have a lot more detail, which I think have the potential to get at this question, which is obviously important. I mean, I have no doubt that these different kinds of spending, it makes a difference.
Right. So there's another question. Well, I think there are two more questions. How are you doing on time? Are you fine to answer
I'm fine.
this?
I'm happy to stay for
Perfect.
longer.
So Arca says, can slow recoveries be explained with rational expectation theory? Can it so happen that as the priors are becoming heavy in a noisy economy, where a noisy economy implies information overload? I am thinking whether rational inattention can be used to explain this phenomenon. How to test this? How can you test this empirically?
Well, I think a couple of things are relevant in terms of the facts. So one thing is that almost the entire sort of slow recovery fact comes from labor force participation. So it's really about labor force participation and not the unemployment rate. And the second fact is that there's this huge difference between men and women. And a big part of the fact is coming from women. So I guess that's something that's sort of central in my mind on these issues, that you want to think about a theory that can kind of make contact with those facts, where it's really somehow about labor force participation, and it appears to be asymmetric between men and women. And I think another thing maybe to have in your mind is just these longer term graphs, that the slow recoveries are a part of these very long term sort of secular trends in employment and labor force participation.
Perfect. So one thing that comes to mind, that's a follow-up question to this of mine, and then I'll go to Gassen's question. Um, so you see an aging population. So what this graph makes me think of is that maybe this reduction in participation is led by men that in a recession they are maybe 50 years or older, and they cannot reinvent themselves or gain new skills and rejoin the labor market, and that makes that keeps happening, and this share of the population keeps increasing. Maybe this is keeping the participation rate. This is lowering the participation rate. Do you know what I mean?
Well, it's striking though that you don't see, traditionally the idea is that the participation rate is sort of an acyclical variable. And I mean, that's not completely true. For example, during the Great Recession, you do see a bigger decline, like kind of
Right.
consistent
Yeah.
with what you're saying. But on the other hand, this line, in general, is not that cyclical. And,
Right.
and so you see a lot of action even between um, recession. So, I mean, I think some version of that, could be an important part of the story, but I think it would have to be probably something that is, applies not just to the recessionary periods themselves, but somehow to periods in between the recessions.
Right. So let's go now to well, we have Ghassan Jabri's question. He says, you highlighted the difficulty of establishing counterfactuals without randomized trials. What is your view on using synthetic control methods in macroeconomics to build these counterfactuals? Do you trust them as much as the natural experiments you highlighted today?
I think this is a question where there's no sort of black and white answer, unfortunately. I think it's probably good for a lot of the questions we have in macroeconomics to have many methods, because obviously with synthetic controls, the challenge is that you only observe so many, covariates. And so you're picking controls. But for example, if I had done the fiscal policy analysis using synthetic controls, I would have had to pick somehow states that were, similar, but it's not clear that are any of the states exactly similar, and what characteristics would I have chosen? So there's sort of a sensitivity to those covariates, and I think that's the challenge with those methods. On the other hand, with natural experiments, there are also challenges. For example, you're only looking at a particular slice of the variation. I was looking at military spending, like one of you mentioned, and that's only one dimension of the variation. In addition, these natural experiments are never perfect. They're not randomized trials, and so there are um, lots of questions that relate to this as well. And often there are other correlations that can raise questions. I think what we always have to be thinking about is sort of how do you assemble the best evidence you have on the important questions. And I think that for many of these macroeconomic questions, we will want to have multiple sources of evidence from multiple different methods to kind of build confidence in what the answers are, because typically, none of these approaches will be perfect. And even when you do have a randomized trial, it might be in a very particular circumstance. I mean, maybe you're trying to measure the marginal propensity to consume and you really have a randomized trial, but perhaps that randomized trial is happening in a particular country at a particular point in time, and there are real questions about, the broader generality of the results. So, I mean, this is why I think that more resources in macroeconomics will hopefully be devoted to these kinds of empirical answers, particularly as we have these new technologies and so on, because I think we need to have multiple estimates to kind of gain confidence in the answers.
Right. So kind of related to this, I saw some time ago an interview to a professor, J. Doyne Farmer, and if I remember correctly, he was a proponent of, using simulating economies, with I guess using the power of supercomputers. Is that something you've thought about? You've tried to implement? How do you, or do you think there's a future to that? Because I know
I think
simulations are a big part of, right, sorry, simulating data is a big part of, testing models and,
right.
but that's like the next level, right? Simulating
Right.
entire
I mean, I
economies.
think, I think these are interesting ideas as well. I think the big challenge is just that our models are nowhere near as accurate as, for example, the standard model in physics. I mean, we're just not even
Right,
close. So I
right,
think that that's the challenge, that um, when we think about simulations from models, we always have to be humble about what we're learning because we know that a lot of the testable predictions of these models aren't validated by the data. And in some cases they're validated in a qualitative sense, but often a quantitative sense is challenging. And so I think that's the main sort of challenge with thinking about how to use simulation methods is how you can
right.
do that in the context of the
Yeah,
models being imperfect.
right. Okay. Anyone else, please, if someone has questions, you can just unmute yourselves and ask the professor. Um,
Should we call it a day?
Yeah, if I think that's it. Thank you very much, Professor, for this insightful talk. Very enriching, and thank you for joining us once again. So
Thank you.
it was very nice to host you.
Great. Bye bye.
Bye.